Did you?
Yes.
Which one? The circle sphere one?
Yes.
That one?
Yes.
Okay. You'll have to show me sometime.
It's square root of 69 divided by 3 plus 3.
Yeah, I know. I don't know how you got it. Have a good day. I'll leave the bell, guys.
This one, 39.0. First, actually, I think because that's
It's just like how
this
like,
multiple questions.
But I have like, it's just like not enough time. They like go for like maybe you have to wait till like 40 minutes later.
You're not giving me like old papers. This is from back in February.
What?
Did you get oscillation?
Last week? Oh yeah, it was. Do you know that? Yeah. See if I remember.
He's doing the thing again. January, February.
Okay, yeah. So what you do?
Oh, no, it's not your
Since it's after the test, I have to turn this on credit or no? I didn't realize that I didn't see this problem.
If you finish them, I'll give you half for calling back.
Okay.
But in general, I don't have one.
Okay. I'll probably get this to you today then. Tomorrow I'm out all day with some business.
He brought X squared. He moved over here, so it became negative X
If it's
squared.
later
And then to get
today,
Y, he did the
that's fine. Or tomorrow's fine.
Okay. Thank you.
Okay, so this is like the big. So that's just like one problem. Yeah, this is This is like the big thing. If you turn, I probably don't explain this is what I'm doing. If you turn y to dy over dx. Wait, actually, I think that's it. If it's ready, I think you should just ask. Take the test. I just thought you were like, you and this.
Okay, I need y'all to get out number 30 from last class and a blank piece of paper for 31. Alright, come take a seat, please. Okay, so after, you guys are going to have to give me some information here. After our test last class, we started on number 30, and I'd like to finish that up and do a quick review of implicit, but each class got a little bit further on assignment handout 30 last time. My second period class had it finished, and it looks like we just ran out of time, right? We did finish? The whole free response? We did parts B and C also? No. Yeah, I want to talk about those as well. Okay, let's all get settled in here, please. So let's first talk about what implicit was. Okay, you guys are going to have to talk about that later, please. I'm not going to talk about it. Let's talk about what implicit was, because this is what we are going to practice today. I've got like a, 12 question book assignment or something for you to practice implicit. This will be the one day where, the one full day I give you on implicit, except for going over parts B and C of that free response. So, implicit was where we take the derivative of stuff now, and sometimes we have to keep track of the variables that we're taking the derivative of. So this example 2, we talked about the derivative of x squared was 2x. So power rule, product rule, quotient rule, chain rule, that stuff is still all the same. I'm not undoing any of that. But you need to think about the variable. If you're taking the derivative of some x stuff with respect to x, that's like dx over dx, and dx over dx is like 1. You can think of it as something divided by itself. So, same idea with 5x. The derivative of 5x would be 5. I'm taking the derivative of x stuff with respect to x. Everything today is with respect to x. The important parts are the highlighted parts. To take the derivative of negative 4y squared, you still do power rule to get negative 8y, but you have to train your brain, just like chain rule, bless you, to say, I just took the derivative of y stuff with respect to x, because dy over dx is probably not going to be 1. So every time we took the derivative of y, we did a dy dx or a y prime, same thing. Took the derivative of y, so we included a dy dx or a y prime, same thing. And that y prime or dy dx is the derivative, and that is what we will be practice solving in the book assignment today. So on the back, I put one FRQ for 2 reasons. One is I wanted you to see that they do ask this on the AP exam. The nice thing is when they ask it on the AP exam, they tend to give you the answer. So if you can do implicit and you stick with it, there's no way that you should miss that, because they're telling you this is what the answer is supposed to look like. So I also kind of want to talk about the scoring of these, because the other reason I wanted to look at this FRQ is I want you guys to see how B and C kind of play out. It's not that these B and C's are common question types on FRQs, but it's good for y'all to see how they like to ask you something that you have done before, but in a slightly different twist that's not super intuitive. This is why FRQs tend to be the hardest part of our AP exam and why we will practice more and more of those as we move forward. Okay, so we already did part A. We took the derivative of this big equation. Notice I highlighted all of our y primes. Every time we took the derivative of y, we did a y prime. So we already did that last time. But 1 point, one of the 9 FRQ points comes from just this first step, showing that you know to do implicit. And then the second point comes from making sure all of your work makes it come out to what they say. Now, part B has nothing to do with implicit, but again, this type of stuff only gets easier the more different things that you see. So that's where I just try to expose you to as much as possible. All right, part B says write the equation of each horizontal tangent line to the curve. What do we know about horizontal lines? Okay, even better. So horizontal lines are when the slope is 0, but in calculus, we like to say when the derivative is 0. So, do we know the derivative of that equation? Yes, they gave it to us, right? Even if we don't know how to do part A, they told us the derivative. So, take the derivative, which represents slope, and understand why you are setting it equal to 0, because setting it equal to 0 is how you get a horizontal line. 0 slope, horizontal line. 0 derivative, horizontal line. I want to pull up the scoring here because I do like you guys to learn how some of these get scored, because a lot of times I think there's points you guys could get if you knew what certain things they were looking for. So right here, if you set the derivative equal to 0, that is already worth 1 point, showing that. So even if you can, this is ends up being so easy for you, you can do it in your head, you need to show that step. Now, you could multiply both sides by the denominator, but when does a fraction equal 0? Good, so we really only care about the top equaling to 0. And here's what I meant by the next 2 steps you have heard thousands of times, maybe literally thousands of times, but it looks different. I need to solve this. How can I solve this?
Factor.
Okay, very good. You could factor out a GCF. Then what?
Set one of the variables equal to 0.
Okay. So if this times this equals 0, you could set this factor equal to 0 and solve, bless you. Or you could set this factor equal to 0 and solve. I know you have heard that 1,000 times. Factor, set each factor equal to 0. But it's different because one of your factors has x's and one of your factors has y's. It's not like it's any harder, it just feels less comfortable. It's not something we practice often. Okay, so I am supposed to come up with an equation of each horizontal tangent line to the curve. So that should happen when x is 0, and it should happen when when y equals 2. Okay, so this was your second point. If you actually solved where the derivative equals 0, and you came up with those 2 values, they give you another point. So some of our answers should come when x is 0 and some come when y is 2. Do you think I should plug 0 in for x and 2 in for y into the original equation or into the derivative? The original. You would only plug it into the derivative if you're interested in something about slope. So I'm looking at this big mess of stuff at the top. I'm copying it down again, but you have it on your page there. So one time we need to go in and plug in x is 0. So you get 2y cubed plus 0 minus 0 plus 6y equals 1. And you would need your calculator to solve that. This is not quadratic, so you can't even use quadratic formula, but it comes out to 0.165, I believe. Yeah. So you get a third point if you come up with that equation. There's one y value for that. Also keep in mind, horizontal lines always have an equation of y equals a number, so this is already in the correct format. Okay, but we may get others by plugging in y equals 2. So if we take the original equation, plug in 2 for y, we get 16 plus 12x squared minus 12x squared plus 12 equals 1. And what happens when we combine like terms here? What cancels? Okay, the x squareds cancel, and you get a statement like 28 equals 1. What does that mean? Right, so this one gives no more solutions. 28 can't equal 1. If all your variables go away, then if it leaves a true statement, it means it's always true. If it leaves an untrue statement, it's always false. They give a fourth point for showing this. So again, even if somehow you could plug 2 in your head, see that you get an untrue statement, realize you don't get any more solutions from that, they expect you to plug it in and address it to get that fourth point. So 2 points for implicit, but at least you knew what the answer was. 4 points for part B. Horizontal lines are when the slope is 0, so the derivative is 0. Setting it equal to 0 gives you 1 point. Solving it gives you another point. Plugging in one of those solutions into the original equation and getting your calculator to solve gives you a third point. And plugging in the other possibility into the original equation to see that it doesn't give you anything else gives you a fourth point. This is not intuitive to most people, but I need y'all to see that 5 months from now you get stuck on a question. You might say, maybe I can factor it and set the factors equal to 0, even if it's got x's and y's. Maybe in a few months you get an answer and you plug it in and you get an untrue statement and you realize, wait, I probably need to show that in my work. I need to show that that doesn't give any more solutions, because sometimes they give a point for that. But again, that stuff does get easier with time. So, all right, the last part. The line through the origin with the slope -1 is tangent to the curve at point P. Find the x and y coordinates of point P. So there's a whole lot going on there. If you expect to just read that statement and say, oh, I'm supposed to do this, 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 and this, here's my answer, it's not usually quite that simple. You got to find something to start off with. So what do they tell me about this line? Okay, it's tangent, which to me, I'm thinking derivative. Tangent lines are like a visual of the derivative. What else do I know about the line?
The slope.
Okay, the slope is -1, and I know it what? It goes through the origin. So they're telling you that stuff, but you need to start, like, you got to focus in on something. You got to figure out some way to start this problem. So I look at this, can't we make an equation that has a slope of 1 and a y-intercept of 0? What would that be?
Y equals -1 minus x x1.
Okay, you're doing point slope. Okay, you could do that if you wanted to, but since most of that's 0, you could just do slope intercept there just as easily. Everybody see that a line that has a slope of -1 that goes through the origin is y equals -x? Again, nobody's giving you a hint to do that. It's just that you can sit here and look at this question all day and you got to do something. So they told me this, I pieced together this, and now this is like substitution. I know what y is in terms of x, so I can go to that original equation and I can substitute. Everywhere there's a y, I can put in a -x, Yeah, can you put it back up there, please? Is that, you have two? Just put it on the charger, thank you. Okay, so why did I do that? How is this better than the step before it? Right, so I've eliminated a variable. By figuring out what y was in terms of x and making that substitution, now I can see I've got this many x cubes, this many x squareds, and if you finish solving this, like you could factor out an x, you could factor out some numbers here, but the fact that we use the calculator in part B tells me we'd use the calculator in part C. So if you finish solving this, you would get that x is negative 1/2, and then you could plug that back into the equation and solve for y, and it's positive 1/2. But for this question, or this part, they give a point if you show that you realize the slope has to be -1. There's a couple different ways you could work this one, but one of the ways is when we plugged in -x for all the y's, just doing that was worth a point. And for this one, you had to get all the way down and solve that for the third point, or the last point. Okay, so B and C aren't going to be really relevant today, but again, I still want you to get something out of these. You guys, like, do you feel like you would do better if you saw part B and part C now? You have some idea of what to do, how to start it. Okay, then what I'd like us to do is let's, so we talked about implicit for just a second, and I told you we have a short book assignment, but let's go ahead on your blank piece of paper. Let's just do number 1 as a group, as a quick little reminder, even though I've already verbalized it. And then you have the rest of class to practice the other, whatever, 10 or 11 questions there are. Johnny, you need to put your phone up again.
So write down the, is that okay?
No, you can't have your phone up for any reasons. I'll put the assignment back up in a minute.
Appreciate it. Thank you.
Okay, so hopefully on your test, how would you have taken the derivative of x squared? Okay, I'm asking you to think about, we just took the derivative of some x stuff, and all of these questions are with respect to x. Dx over dx is like 1, multiplying by 1 doesn't change anything. The derivative of x squared is what you've been doing for the last couple weeks. If we just get to use power rule here, then we get to just use power rule here also. Bring the power down, lower the power by 1, but this time you need to be thinking, I took the derivative of some y stuff with respect to x, and this is not 1. This is not something divided by itself. So you either need to make sure you have a dy dx or a y prime. Same thing. Okay, and then I still left the most, not the most, but one of the most common mistakes down here. What did I glance over?
Doing the derivative of the other side.
Right. Don't take the derivative of the left side if you're not going to take the derivative of the right side. And the purpose of these questions is trying to find derivative. So here it is. We just need to algebraically solve for it and practice simplifying until our answers match up with what the back of the book has. So like I've been doing, these are not yours to keep. These are not yours to write on. The back page does have the odd answers. Every answer we're doing today is odd. So if you start solving this and you subtract the 2x over, and then you undo times with divide, that's fine to think that's the answer, but when you check the answer in the back, it's not going to look like that because they're going to at least divide out the 2's. So Again, just like last unit, it's unfortunate, but I can't tell you exactly how much to simplify. Sometimes the simplifying is several steps and it's a pain. Sometimes it's pretty basic like this, but just a good benchmark is to try to make sure it looks like what they provided. Okay, so one time I took the derivative of a y thing, so I created one y prime. Everybody okay with that? The highlighted step's the only thing new with implicit. Still power rule, still occasionally product rule, very rarely still quotient rule, still chain rule, all the stuff we've been doing, we're just adding one extra step. Okay, I would like you to go ahead and get started. So copy the rest of the assignment down, please. Try 3, check it in the back. If it's right, move on to 5. If it's right, move on to 7. And because this is so short, I know most of you will finish in class today. So if you finish in class, I would like you to go ahead and turn it in so I can give you the homework points and get it back to you. I will say though that if this takes you a little bit longer to catch on and you don't finish it in class, I will still take it tomorrow for full points. Tomorrow's a B day, so I will see you again. And I have all of these worked out on the website. So if there's any that you need help with and you just run out of time on in class, you should still be able to catch up to everybody else. But for right now, copy the assignment down, start the first one, see how it goes, and then I will interject and try to help out anywhere where y'all might struggle. I will add that I'm not going to come around the classroom too much today and help out individually. I do try to do that quite a bit for calculus, but if you can't hear, my voice is getting kind of scratchy. I'm afraid I'm starting to come down with something, so I'm trying to stay away from y'all as much as possible. So I hope it is good. Okay, anybody still need to copy the assignment down? Okay, for those of you that need help with number 3, if you're getting stuck or your answer's not matching up, this derivative should give you that. If you want to keep up with the dx over dx, you can, but multiplying by 1 doesn't change anything. This is the exact same thing with a y, so power rule is going to work the exact same way, but in this case, you're taking the derivative of y with respect to x, and if you don't include that, it will be wrong. Now, it's the only y prime, so in this question, if you forget it, you know something's off because that's what you're supposed to be solving for. And if you don't have one, then you have nothing to solve for. So there's the calculus, and then simplifying the algebra, we could subtract this x stuff over. We could multiply both sides by 2 and multiply both sides by square root of y. And then this is the derivative, so it would make sense for you to start to look at your answer choices or look at the answer in the back of the book. This isn't how they have it look though, so you might not remember this property. Do y'all remember how to take the square root of a fraction like this?
Square root of the top and square root of the bottom.
Right, square root of the top over the square root of the bottom. 1/2 times 1/2 is what gives you 1/4. So they're just going the opposite direction. Instead of 2 separate ones, they write it as 1 big square root. So make sure that you realize these two are equivalent in case you ever see that. So again, same old stuff, still getting better at the simplifying, still getting better at product rule, quotient rule, chain rule, all of that stuff. That stuff gets easier and easier and you get more confident and quicker on it. But I cannot stress enough the highlighted steps how important that is. Every time you take the derivative of y, you have to create a y prime. Also, the topic we will be doing tomorrow is we'll be starting some related rate stuff, and related rates kind of works the same way. Related rates, we take the derivative with respect to time. So every time you take the derivative of x, you need an x prime. And every time you take the derivative of y, you need a y prime, because x and y are not the same thing as t. Same thing that we're doing here. Every time we took the derivative of y, we need a y prime, because y is not the same as x. So, okay. Does anybody have anything left over about question 3? Okay. Let me give a few more minutes, and then I will go over question 5 also, and then after that I'll just take whichever ones you guys have. if you're still haven't got number 5 worked out, I am about to go over it to help out. Now, certainly nothing wrong with trying to pick off the easier stuff. X cubed becomes 3x squared. Y squared becomes 2y. Just make sure you remember the y prime. Every time you take the derivative of y, you need a y prime. Derivative of a constant is going to be 0. And then the part that I'm most concerned about, the part you need to be most careful about, is this middle piece. This is minus, and there's nothing I can do to force these two together. There's no algebra, fraction rules, exponent rules. I can't simplify x times y. The only way I can take the derivative of x times y is with product rule. Take the derivative of x with y left alone plus x left alone times the derivative of y. And since I'm taking the derivative of y again, I need another y prime. Now, I purposely left a mistake here because I'm afraid this is going to be a common mistake for y'all as well. What did I not do? Negative where? This? Very good. So right here, this was supposed to be minus xy. So after you do the derivative, it's still minus the derivative of xy. You need to either put parentheses or you need to distribute it right off the bat. So it's a minus y and a minus xy prime. Now, these questions also can be a pain to simplify. I don't think they're as bad as the questions in Unit 2. Unit 2 questions are the hardest to simplify of all the stuff we do all year. I'm not saying that they're the hardest questions, but they're the biggest pain to simplify sometimes. But the nice thing about these questions is it's usually pretty formulaic. The last few steps is very common. If you've got more than one y prime, leave that stuff on one side. Move the other stuff to the other side. In mathematics, we call that isolating the variable. I'm isolating the y primes. And the reason that you want to do that, the way you're going to remember to do that, is if this term and this term both have a y prime, you can factor it out as the GCF. And then after you do that, you can always undo times with divide. Okay, so you do that on the test, you get your answer, you look at the answer choices. The answer choices don't look like this, but they just swap these two around and they swap those two around, but those are certainly equal, so that's fine. As long as you can recognize why those are the same. There's no rhyme or reason why they mix these two up or switch these two, but could have just taken a different approach, or they just may want to see if you realize those are equivalent. So once again, I took the derivative of y twice. That's why I had two y primes. I've got both of those highlighted. Every single time you take the derivative of y, you need a y prime. If you do it sometimes, questions like this, you will miss. No matter how much time, effort, or frustration you have, you won't get it if you don't do it every single time. Okay, does anybody have a specific question about number 5 while it's still up? Yeah.
So if there's multiple weapons, you just always factor it out.
Yeah, get everything with y prime on one side so that you can factor it out, and then after you factor it out, you can undo the times with divide. Okay, so again, you guys know I'm happy to help out with as many and all the questions we have time for. But I don't want us to waste time on anything that we don't need help on. So if you have not moved on to question 7 yet, please do. And if you don't end up with that as an answer, what they get, then obviously I will offer to work it out for you to help. But let's give everybody a couple minutes to at least try it first. And then Johnny will work it for us.
When am I working? I'll do it on the iPad.
Mr. Johnson, I had a question about right here. They had these two terms like together, but I just took this one and added it over here before, like doing this stuff. Well, how come I'm not allowed to do that?
Okay, so right here, the derivative of minus y is not negative 1.
Oh, it should be negative y prime.
Right. Just like when you took the derivative of y there, you did a y prime.
Right.
You're taking the derivative there too, so that's also a y prime. And y prime's not the same as a constant, so you can't push those together.
Yeah, thank you.
Johnny, you're doing 9 through 47.
9 through 47.
Yeah.
I'm on it. Right now?
Do you have number 7 done?
I have, no, I don't.
Do you have number 5 done?
I can do 5 though.
You can do 5?
Can we do it on there? Or just explain it?
On the board?
Yeah.
Number 5? Can you see with your glasses on?
We can now. I can try. Sure. I'll give it a shot. This is done right, so never mind. This. I can do 7 for you. I can do 7 for you.
Okay, I will stick with you on number 9 until you tell me that you found your mistake. Okay, what's the derivative of 0?
The derivative of 0 is 0.
Okay, what about 3y?
It would be 3. And then dy over dx, or y prime.
Okay, either one. Minus 10x would be,
Negative 10.
okay, good. So the real problem here is this one. So did you do product rule? Good. So take the derivative of x, which would be 1, times y prime left alone, plus, now leave x alone, times the derivative of e to the y. What is e to the y?
E to the y.
What's the derivative of e to the y?
Would it be e to the y dy dx?
Yes,
Y prime?
because you're taking the derivative of something to do with y.
Okay.
So it's really, you guys don't have to know that that's chain rule, but it's really chain rule because when you do this, you're taking the derivative of the outer with the inner plugged in times the derivative of the inner.
Okay.
So implicit's really just an application of chain rule. But
Okay.
is that all you needed?
Mhm.
Okay, we can finish it later if you need to. Okay, here, let me give you another minute.
I have a question.
Mhm.
So for these, would I have to use the product rule since they're being multiplied together? Okay, just
This is not cosine times 2y, it's cosine of 2y.
okay.
So, no, you don't have to do product there. Okay, now that you've all had time to look at 7, is anybody stuck on 7, need help with it? Not yet? Okay, I'll give you more time. Okay, so let's try to catch everybody back up. Anybody still need help with number 7? Last call on number 7. What about number 9? Finishing number 9. Okay, how about number 10?
Was number 10 on the list?
No, I'm just seeing if y'all are paying attention. How about 11? 11? Okay. Again, you're welcome. As always, you can either jump to question 11, even if you're not there yet, or I do have this worked out on the website, so if you need to watch that video outside of class, you should get the same information. Okay, so a couple of these parts shouldn't give you too much issue. The derivative of sine is cosine. We use that so much we memorize it. The derivative of a constant is 0. Use that property so much we like to memorize it. But right here, you've got 2 times cosine something. And the derivative of 2 cosine something is negative 2 sine something. But the something does not have a derivative of 1. There's an inside here. What's the derivative of 2y? Very good. So if you just do 2 and you forget the y prime, notice there's no y prime to solve for. But when you take the derivative of 2y, you're taking the derivative of a y thing, so you need a y prime. And that is what you're trying to solve for. So this can move over. Subtract the cosine x over, and then you can divide away all of this stuff that's being multiplied by y prime. And I'm sure they will cancel out the negative over a negative and call it positive. So that's what I would go with. 11, that's what they have. So again, it's pretty obvious that this is the hardest part of the question. But the derivative, first off, the 2 just carries down. That's the constant multiple rule. If you'd rather do product rule and think of it as 2 times cosine of some stuff, you can. It's just completely unnecessary. So derivative of cosine something is negative sine something. And then I did chain rule because the derivative of 2y is not 1. And then when I took the chain rule, I did implicit. So sometimes you do implicit within chain, within product. It all piles up. Yep.
Could you do 13?
I will. Is everybody okay with 11 now? Okay, I also had a question for 13. Now, my question on 13, because you could start this 2 different ways, which is going to change your work a little bit. I don't know that one's really better than the other. But did you distribute this x or not?
I did.
You did, okay. If you don't, you can do product rule with this whole thing. It's x times this stuff. But I agree. I would probably just distribute the x. I think that's just a little nicer to look at. So the derivative of sine is still cosine. The derivative of x is still 1. But the derivative of this mess, you've got to slow down. And we're going to have to do product rule. We're going to have to know the derivative of tangent. We're going to have to remember to do implicit. We got lots of stuff going on here. So this is x times tangent y. That's how I know it's product rule. So the derivative of x times tangent of y left alone plus x left alone times the derivative of tangent y. And what's the derivative of tangent something?
Secant squared.
Secant squared of the something. And I just took the derivative of a y thing, so I also need a y prime. That's the one and only time you took the derivative of y, so that's the only time you need a y prime. This part of the product rule, I wasn't taking the derivative of y, I was leaving it alone. So we could take this cosine x and we could subtract the 1 to the other side. We could subtract the tangent of y to the other side. And then if we were trying to solve for y prime, we can just get rid of all this other stuff with division. So in the end, y prime the only thing they did is they switched these two. Otherwise, it's exactly the same. Okay, got what you needed out of that?
Did you do 15?
Everybody done with 13? Nobody has follow-up to 13? I can put it back up later if y'all need it. I just... Okay, so for 15, what's the derivative of y?
Y prime.
Very good. 1 y prime. The derivative of sine something is cosine something. The something doesn't have a derivative of 1, so chain rule says we need to multiply by the derivative of xy. What derivative rule would that be? Okay, it is chain rule, but to do the chain rule, to do the derivative of x times y, that's going to be product rule. So derivative of x times y left alone plus x left alone times the derivative of y. Took the derivative of y, so there's a y prime. Okay to here? Okay, then it looks like we could probably distribute to get rid of the parentheses. So I'm gonna, I know I need to isolate the y primes. There's no way for me to get all the y primes on the left or the right side if this y prime is like stuck in this parentheses. So if I distribute, I can dig this y prime out of the parentheses, and then I could subtract that mess over. And the reason I know I should try that, I'm not just doing random steps here, is because now both of these have a y prime, so you can factor out the y prime and undo times with divide, just like how most of these questions finish. So I would anticipate the derivative to be y cosine xy over 1 minus x cosine xy. And that's exactly how they did it. So again, implicit, knowing the derivative of sine, chain rule, implicit, product rule, and then algebra. That's where I said if you don't have a decent understanding of product rule and power rule and all that chain rule and stuff, it only gets harder. So. Okay, I don't think most people are past question 15 yet, so I'm going to slow down just a little bit here. I'll leave 15 up for a few minutes for those of you that still need it, and I'll come back.
This one, I got y prime equals 0. So did you just not do anything, or did I do it wrong?
Okay, you're trying to find the equation of a tangent line, so your answer should be an equation.
Okay, so.
But this just tells you the slope.
Oh, yeah.
But you want the whole equation, so plug the point and the slope in the point slope, and then it should look like theirs. Yeah. Okay, did anybody have any question before 15 that you need help with? Okay, I don't know what was after 15, but 17 or 19. Uh-huh. Okay, so for 17, what did you get for this part? X squared becomes, okay, I agree. What did you get for this part?
I wasn't sure whether it was 3 over y prime or 1 over 3 y prime.
Okay, first you said, well, there's a minus, so let's put that down and forget that. First you said 3, 1 over y prime is the first thing you said. What was the second thing you said?
The 3 was already on the bottom for the second one.
Oh, okay. Yeah, so you're not taking the natural log of 3y. If it was that, then yeah, the 3 would be in the denominator. But it's not part of that. So this is going to be negative 3 times the derivative of natural log of y. The derivative of natural log of something is 1 over something. And since it was a y thing, you also, in addition, need a y prime. So the first one you said was correct. But okay, and then y squared becomes 2y, but you're taking the derivative of the y, so you better put a y prime. And the derivative of the constant is 0. Okay, to keep going here, I could subtract this 2x over. Because it doesn't have a y prime, I could factor out a y prime like we've done in most of these questions. I can undo times with divide like most of these questions. And I still have one thing I'm concerned about. This, before I even turn to the back to look at, see if this is the answer, I know they're not going to leave the answer like this. How do I know the answer is not going to look like that? Alright, this is a complex fraction. Anytime you've got small fractions within a big fraction, nobody's ever going to leave their answer that way. So the good news is, to simplify this complex fraction is the same way we simplified it in limits, the same way we simplified it in Unit 2, same way that you should have done in algebra and pre-calculus. You want to multiply this by y, so you've got to multiply everything by y. I would expect their answer to look like that, or something very similar to that. Yeah, they multiplied the top by a -1 and the bottom by a -1. Again, no rhyme or reason why they multiplied the top and the bottom by -1, but it's easy enough to compare my answer to theirs since it is the same. Yeah.
So if we weren't to simplify it like that, would we not get the point?
Here?
Yeah, like how they how they multiplied it by -1.
Oh,
Would we still get the point if we didn't multiply it by -1?
depends on what type of question it is. If it's a free response question that just asks for the derivative, you could stop way back here. In fact, you can leave it in complex fraction form. If your answer is technically equivalent to the derivative answer, I have to count it right. So it's unfortunate for me because that's a lot of work. If it's a multiple choice answer, this just doesn't match the correct answer. So yeah, if you can't figure out how to simplify this to this and this to this, then you could miss it.
Right.
So that's where we practice the hassle of the simplifying so that when we have to for multiple choice, we can if we need to. So just depends on the question.
Thank you.
I don't remember who asked this one, but Brody, it was you. Is that enough? Now, of course, if you did not trust me the first time and you didn't believe me that you're going to need to know the derivative of natural log of x and the derivative of e to the x and the derivative of the trig function, you can start the product rule. If you didn't really believe me that that stuff was going to stick around after Unit 2, you should believe me now. And of course, you can always go back and catch yourself back up. But yeah. Yes, please. I'll bring it right back.
Wait, I didn't write this down.
Because I did that and I got this on that. Right now it's 2y squared minus 12 x squared y squared. 1 plus 2y squared.
1 plus 2 by 2. You're really close.
Right, if you have my denominator and I have your numerator, I have that. I don't have it. Let's do it.
Okay, it looks like there's only a couple we haven't looked at. Has anyone realized they need help with 19? Okay. Okay, 4x cubed is going to become 12x squared. Natural log of y squared is why I'm guessing you're probably asking this question. What does 2y become? Okay. And 2x becomes 2. So it's really this guy that we need to be the most careful about. So to take the derivative of natural log of something, it's going to be 1 over something. Just like the derivative of natural log of x is 1 over x. But this has an inside, and the inside's derivative is not 1. What is the derivative of the inside? And within that, we're taking the derivative of a y thing, so we need a y prime. So we had to do chain rule, and within chain rule, we had to do implicit. 1 over y squared because it's natural log, times the derivative of the inside because of chain rule, and because we're taking the derivative of y, we need a y prime. Now, at least this and this can cancel. Looks like if you isolate the y primes, it looks something like that. And then you can factor out, undo times with divide, and then we should be close. Now, just like a question or two ago, I know there's no point in me even looking at the answer yet, because I know there's no way this is as simplified as they're going to make it. This complex fraction, we're going to multiply this guy by y, which means every term needs to be multiplied by y. Also, I see that if I factored out a 2 from the top and a 2 from the bottom, the 2's could cancel, or you can just divide everything by 2. And that's what I would think the answer probably looks like. And they did one more thing. Bless you. They factored out the y. But 2 times taking the derivative of y, so 2y primes. Yeah.
47.
Okay. All right. You do need, your answer is going to look wildly different to 45 and 47 if you don't read the directions there. This did not just say find the derivative. It wants you to write an equation of a tangent line at this point. So before I even worry about dealing with this, I know it's going to be implicit differentiation because that's what we're practicing today. But as soon as I read in the directions, equation of tangent line, tangent lines are always linear. So point slope is the best way to go. They already gave you the x value. They already gave you the y value. The only other mystery to this question is the slope. And you have to understand slope comes from derivative. So I can take the derivative of this big mess by doing 1 plus 1 y prime plus 0 equals, take the derivative of natural log of something, you need 1 over the something times the derivative of the something for chain rule. And within the chain rule, you're taking the derivative of the y, so you need another y prime. Now, you can simplify this if you want to. You can solve this all the way down for y prime, but this is one of the few times you don't really need to, because you really only care about the slope at this time. So personally, I would just plug in a 1 everywhere there's an x, a 0 everywhere there's a y. Just make sure you realize that y and y prime are two different things. This is 1 times 2 plus 0. Y prime is 2, so 1. And all of that to figure out that the slope at the point 1, 0 is 1. So that could be the equation of the tangent line. Of course, subtracting 0 doesn't do anything. Timesing by 1 doesn't do anything. So they probably wrote it like that. Yes, and that's what they did. I checked. But equation of tangent line, started with this, plugged in the two things they gave me right away, and then we had to dig deeper for the slope. Slope, when you need slope, you need to think of derivative. When you need derivative, sometimes you need to think of slope. Just those two are interchangeable. Okay, if you have work you'd like me to look at to help you with, just let me know. Thank you. If you do finish with more than a couple minutes left, go ahead and turn it in to me with your name on it. I will in a second. If you don't finish up in class and you need to finish up for homework, that's fine. But again, just make sure you realize tomorrow is B-Day again, so you need to make sure you get it done tonight. Any of them you need help with, I've got class videos for.
So on this one, if I put X here, does it matter if it's in front or behind?
Yeah, yes, it does. The way you wrote that looks like secant squared of xy.
So this is the X times.
Now,
secant
if it was secant squared of x times y,
Yeah,
you could put the x in parentheses and I would know that it was times y. But the way you wrote it, I would have to assume it's part of the secant squared.
squared. Okay. Thank you.
Can I do 45? I can. Can you do 45? Uh, 4xy equals 9 through this point. Okay, same directions as last question. Come up with the equation of a tangent line. Start with point slope. They already gave you the point. Point slope. Plugged in the x value of the point into x1, the y value of the point in for y1. You okay with that part? Okay, so the calculus part comes from trying to figure out the slope during this time. So that would be derivative. Now, totally optional, but I would probably divide both sides by 4. I just think that looks a little bit better. That way the derivative of the right side is just a big 0. The derivative of the left side, you're going to have to use product rule. That's derivative of x with y left alone plus x left alone times the derivative of y. Since I'm taking the derivative of y, that's where it comes from. And I mean, this is easy enough to solve for y prime if you want to, but you don't need to in this question. You really just need to plug this in and solve for this. Everywhere there's a y, I would put 9/4. Everywhere there's an x, I would plug in a 1. So the slope at that point is negative 9/4, and I'm getting that from the derivative. Oh, and again, free response, I think you're crazy to do anything other than this. The more work you do, the more chances you open yourself up to make a careless mistake and then miss the problem. But I do think on this question, I think they put this in slope-intercept, if I remember right. So you could always just distribute this negative 9/4, and then you could add 9/4 to both sides. 9/4 plus 9/4 is 18/4, which is the same thing as 9/2. I think that's how they end up writing it, but it's the same thing. Alright, so once again, just make sure that you know where to get help if you need it. Make sure you know I'm going to expect you to turn it in at the start of next class for full points. And,
I had 2 papers. Oh. I threw a lot.
Alright, y'all did this already?
Yeah.
Yes? Did you do that one already? Okay. If you get the answer to this one, don't say it out loud, please.
Wait, what do you want?
Oh my god.
Yeah. Right here. We've got 2 2 y primes, I think you should only need 1. So when you did this, take the derivative of natural log of y, you need a 1 over y. So I'm good with this over y. But you really should have put that over here like this guy. So if you're doing derivative here and derivative here, then you need to be doing derivative here. So this should be 3 times 1 over y times a y prime. So if you just change that to 1 over y, then that would be fine. Times the y prime. If you already have that. It looks like you did part of the derivative and then another part, and then you tried to finish it in the next step.
Oh, I need to put one on it.
So both these have the y prime. So you should subtract it to that. Factor out the y prime.
Will.
Stand outside. So he would get a good seat for I think so, right? He definitely said something about that guy. Actually, he was supposed to get there at noon, so he was like first to get on the line. Yeah, actually, that's crazy.
But you did that.
Yeah, I mean, I can't confirm, but I think I remember him saying something like that, and then he was going up. Oh, we was at the Zoe, it's just, he was either pre-gaming or.
We don't turn it to 30, right?
No, not yet. Does anybody know the answer? 87? What's the first parking spot number? No, it's 16. What's the second parking lot number?
6. Wait. It's upside down.
This is parking spot 1. This says 16. This is parking spot 2. It says 6. It says 6. 06 is 6. But why would you number parking lot 6 as 06?
90.
Yeah, they're all upside down. If you turn upside down, you can see that they're all in order. It's 86, 87, 88, 89, 90, 91. That should be your hint that they were upside down.